Hello once again, our most valued student. My name is Confident and welcome to our continuation of this revision series, and this is the ultimate guide for you who are doing your grade 10 physical science, and the topic for this term is the waves, sound and light. So we've looked at quite a number of topics. We have already looked at transverse pulses, then we looked at transverse waves, longitudinal waves, we looked at sound and ultrasound. So I'll encourage you go through the previous videos so that you can get this. If you are not subscribed, subscription helps you to follow up on these lessons. So for example, let's say you miss out 2 lessons. The moment you go back to your YouTube, it will show you all the lessons that you've missed out. YouTube is so good like that. So subscribe now so that you can follow up, become a part of this family. This is the 24-minute lesson. And then now the next one is the electromagnetic radiation. That's where we are looking at now, on the electromagnetic radiation. And under the electromagnetic radiation, we are saying, what is it? Electromagnetic radiation, they will ask you actually, what is it? What is electromagnetic radiation? Or how is it formed or propagated? That's the word they use. How is it propagated? Sometimes it's a simple answer they need to say electromagnetic radiation are the accelerating charges. That's it. Accelerating charges generate what? Electromagnetic radiation. Or the question, as you say, they will say, how is it generated? You just say by the accelerating charges. So as these charges are accelerating, electromagnetic radiation is propagated. All right. So now electromagnetic radiation propagation, again an important statement here. This is just something that you need for your exam. What I say says electromagnetic waves are propagated when accelerating charges move perpendicular to the direction of propagation, therefore induces a magnetic field resulting in an electromagnetic wave. Actually, it's the perpendicular between the electric field and the magnetic field. So as these change, I'll say this is the electric field and this is the magnetic field. So they are at 90 degrees perpendicular to each other. As these oscillate between electric and magnetic field, an electromagnetic radiation is produced. Now the next part we are gonna look at is for you to understand the dual nature of electromagnetic radiation. Dual means double nature. So one of the examples of electromagnetic radiation is light, the light that you see every day. So light has 2 types of behavior. At times light shows to behave like a wave. So light shows a wave-like behavior. For example, what are the wave-like behavior in light? There is interference. Remember, constructive interference, destructive interference, such as superposition is another word, and then polarization, that is the wave-like behavior of light. So it can show those characteristics. At the same time, light behaves like a stream of particles. For example, in photoelectric effect, which you're going to learn at a later stage in grade 12. So the fact that light can have this type of 2 behaviors, it can behave like a wave, and then it can behave like a stream of particles. This is called the dual nature. That's what makes electromagnetic radiation unique. Unlike the waves, we did look at the mechanical wave, which is the transverse, and the longitudinal wave. Now this electromagnetic wave has got a double nature, which is it behaves like a wave. At the same time, it has also a behavior of as if it is a stream of particles. Now we use 2 models to explain electromagnetic radiation. And what is the model? The first model is called the wave model, where we look at it when it's behaving like a wave. And then we've got the particle model, when light starts behaving like a particle. Now this double nature is called the wave-particle duality. So whenever you listen to or you start reading about electromagnetic radiation, you will be introduced to this term wave-particle duality, meaning it behaves like a wave at one time. It shows wave like particles, such as what? as we said, such as interference, and then it behaves like particles, such as in photoelectric effect. Now the next important one is the electromagnetic spectrum. They will expect you to know the arrangement of the electromagnetic wave in order of what? Increasing frequency, or in order of decreasing wavelength. So look at it, this is the arrangement, and in here you can see that frequency is increasing this direction. This is increasing what? Increasing frequency. But don't forget, as frequency is increasing, the wavelength will decrease. It's the opposite. And then with increasing frequency, you can also look at this direction. When frequency is increasing, this is the increase in penetrating ability. So the ability of the waves to penetrate, or increasing energy. So what do you mean? Obviously, radio waves at the beginning, it means they have low energy. Gamma rays are high energy or high penetrating rays. So these are the two extremes. If I give you radio waves, these are low, actually they are not even penetrating. These are low frequency waves. Gamma rays, high frequency, high penetrating waves. So how do you simply master this? What do you use if ever you want to master this? I just want to, in my mind, I just want to, in your mind actually, I want to impress this, or to just stick this to your mind. You don't need to sometimes cram these words. Sometimes they come with this. You see, like here, Raul's mother is visiting Uncle Xavier's garden, or Ramilaxi. You can do that. You can use these. Where R is the radio waves, there, look at this, R, the radio waves, M is the microwaves, I is the infrared, V is the visible light, U is the ultraviolet, X is the X-rays, and G is the gamma rays. Or Ramilaxi is the same, R radio wave, M microwave, I, L, U, X, Y. Still fine, but what do I use? I prefer to be able to do this. What if I forget this statement altogether? So what do? I try to put some images in my mind concerning these waves. The first one I will say is, what is the most important gadget that you always have? Always. It's a what? It's a cell phone. These days, you can't do without a cell phone. I mean, your WhatsApp and everything is in your cell phone. Now, in your cell phone, what are you going to use to listen to your FM radio with your earphones? You use radio waves. So you start there. The most important gadget currently is your cell phone that you can use every day. That's where you get your radio waves. Are you with me? And then, once you know the first one, the most dangerous waves that you never want to come across is the end, gamma rays. Very dangerous. These, you always remind yourself, what is the safest one? Radio. What is the last one? Gamma. Radio, gamma. Once you master these, in between, then you can play around also. After that, you're saying, okay, I've got my cell phone in my hand and I know the dangerous ones I'll never have to come across are the gamma rays. You say, when I go into my house, or into your house, yes, that's your house. When you go to the house, you enter that kitchen. There are two ways. You are hungry and you want to eat. There are two different gadgets you're going to use. It's either you choose the stove, or you choose to warm your food with the what? With the microwave. But you're very hungry and you want to warm it fast. You want to cook those noodles fast, or you want to warm that food fast. What are you going to choose? You're going to choose the microwave. That's where you get number 2. You choose your microwave over the stove. And if you are going to cook with the stove, that is when you want to take your time. That's where you find the red part of that stove. Or you want to bake, the red part of that element gives you infrared. That red is the infrared. So let's repeat again. You are with your cell phone, and what are you gonna get from your cell phone is the radio waves. From the radio wave, you are hungry from school or from work. the first thing you're going to get into the kitchen to warm your food faster is the microwave. Now, when you start cooking, you switch on your stove turns red. Have you seen that redness in the plate, or the redness of the filament or the rings in the oven, that stove in the baking? When you're baking, there is that red element that gives you the red heat. That's infrared. All right. And then you continue to say, now it's dark, you want to switch on the lights. You see, that's the light. When it's dark in the house, when you're cooking, you are turning on the light. Then that's where you have the visible light. But the simpler one here is, see yourself opening up the curtains in the morning to see the sunlight. What are you needing there? You are needing, or you are looking for, the visible light. But as they always tell you, don't stay too long in the sunlight. Don't stay too long, because sunlight is dangerous. You need a sunscreen. Remember, when you're going for the beach, in the beach you need a sunscreen. What are you protecting yourself from? From UV. That's why it's got a UV factor of, they will tell you, UV factor of 40. So you're protecting yourself from the ultraviolet. Are you seeing that? And then from there, you go to the doctor for a checkup, but you just feel yourself not fine. They say, let's take you to the X-ray. That's where you get the X-rays. And from the X-rays, I told you the last one is always the gamma rays. I think, as I said, I was trying to prepare. I was trying to put some images in your mind which need you not to sometimes use the words. If you want to use the words, it's fine. But look at this. When you're having, see your cell phone. If I talk about cell phone, you think of radio wave. If I say go to the kitchen, you're going to find two things in the kitchen. You're going to find the microwave and stove. So when you see the microwave, automatically it's the microwave. Start with the microwave. It's faster than the stove. The stove gives you the red part, which is the infrared. And then you're opening the curtains. When you see the sunlight, what are you seeing? The light. That's the visible light. But be careful. Protect yourself from the sun by using what? The sun protection factor, the sunscreens or the sunglasses. Why are you protecting yourself? From ultraviolet. And then when you go to the hospital for a checkup, what are they checking up? They use the X-rays, and the dangerous one is gamma rays. So the moment there's cell phones, remember, cell phones, you are safe with the cell phone side, but you are very, very dangerous with the gamma rays. Those are the things that you can use, guys. Whatever case, you need to master the sequence. Either you start from radio, low penetration. Remember, they want you to do that, low penetration, and to gamma, it's high penetration. So it's up to you how you want to start. If you start from gamma rays, you must know from high penetration to low penetration. The questions, they play around that a lot. All right, so let's move on here. The next thing is a summary, but your books are going to give you more information in your textbook. But these are the summaries you need to know whenever they talk of these. Radio waves, we said they are low energy waves. They have the longest wavelength. This is the order. So that's your number one, radio wave. Uses they will need to know for radio communication, broadcasting, satellite television. Dangers, let's leave it there for now. Microwave, the microwave ovens, you find them there for satellite communications, for speed trapping devices. When they are police are using the traffic, police are using that as for speed, for overspeeding. If you want to check that you are overspeeding, they use these microwaves. Also used in cell phones. Those cell phone towers, they use the microwave. So they use it in dangers. They always talk about cell phone radiation, but we're going to look at it later, which can cause eye cancer, hearing loss, birth defects, and loss of balance. And then, so this is dangers that they will also ask you in general. So they will ask you, microwaves, where do we use them, or what do we benefit from them? And then infrared, where do you use infrared? For the conventional ovens, I told you that redness in the stove is the microwave. And the night vision cameras, they use microwave. And for tracking devices, what about the dangers? Of course, in general, you can get burned. You know, a stove can burn you. Visible light. Visible light, we benefit from the normal lighting from the sun so that we can see from darkness to light, for the normal lighting, and we see lighting, or we use it also in the lighting bulbs. Ultraviolet light, this is where things start getting dangerous. Now these now become penetrating. This is low energy, these now become high energy. They start the high energy waves. So they are used, you see, they are now used to kill microbes. Now the word microbes there, you just think of things like bacteria, viruses, fungi, bacteria, the viruses, the fungi, the germs, anything that is not needed, especially in a hospital. So they are used to kill microbes and for sterilization in hospitals. They are also used in fluorescent light bulbs, the ones that you use in the house, those energy saver lights. They use it in forensic science, and then our body also uses it to form vitamin D. There is one disease, they call it jaundice, that yellowness in the skin when babies are born. Those babies, they are put in a low concentration of UV so that it can cure the jaundice, and then the body then will be needing vitamin D. Now look at the dangers. Overexposure can damage skin cells. That's why you need some UV protectors like the sunscreens or the sunglasses. It can cause blisters and also can cause skin cancer. That's why also it's important to protect your eyes so that they don't cause cataracts. It can also cause it can cause eye cancer. Eye cancer. This is the UV. You need to be careful of the UV light. That's why you can't look directly into the sun. X-rays, these are high energy again, used by doctors and dentists. X-rays can penetrate through the softer tissue such as the skin, flesh, but not through the bones and teeth. X-rays that pass through the flesh show as white images, and those that are absorbed by the bones and teeth, they show as dark images. So that's how they check if you have a broken bone or you've got a fractured bone, and like that. And then also X-rays are used as security checks at airports or in buildings it's also used to determine the atomic structure. So when you talk about X-rays, don't forget, number one, they're used by doctors and dentists in the hospitals. Two, they're used at security checks in airports. That's why whenever they check in buildings to say guns are not allowed, they put your bag through a certain machine that is an X-ray machine that checks what is inside your bag. But they are dangerous. They can cause what? They can cause cancer. They can destroy cells. Too much exposure can destroy cells and can cause hair loss. Alright. Gamma rays, these are high energy rays. They're used to kill also cancer cells. So if you want to treat cancer cells such as tumors, they call it radiotherapy. So you say, I'm going for radiotherapy, they expose you to gamma rays. They are also used to kill bacteria and also to sterilize instruments. But this is not common. The most common one for sterilization, I told you, is the UV. They are also used to keep food fresh longer. Now, what is the dangers? They can cause cancer. In as much as they can cure cancer, they can cause cancer. They can destroy cells. They can cause mutations. They can alter your DNA or your chromosomes or your RNA. They can alter this if you are doing life science. Now, let's look at the radiation from cell phones. Also important. Overexposure to cell phone radiation affects the growth of what? Growth, development, especially in babies if they are exposed. That's why they say when you're sleeping, don't sleep with your cell phone, but put it far away from you, because it does affect growth, development. The radiation from cell phones, it increases the risk of brain tumors. It causes the growth of leukemia cells. It causes eye cancer. It causes birth defects. It causes hearing loss and loss of balance. So they will ask you such things as you look at these waves. Now guys, the lesson will end there, but now the next part of the lesson, that's where I'm going to look at the equations, where we now deal with calculations. So I'll encourage you to join me in the next lesson, where now I'm going to look at the calculation for the electromagnetic radiation. You see, where we're going to do calculations using E for the energy, is HF, which is HC over lambda, as well as C is F lambda. These are very important for you to know. Just look at the calculations that are coming here. See, previous papers that I just brought in, but it prepares you for your exams. All right, join me again in the next lesson. Thank you.